Okay, so today we're going to start section 3 of chapter 3, and today we're going to learn how to prove lines are parallel. So what we're going to be using are the exact same theorems that we learned in 3.2, but we're going to turn them into the converse. And if you remember back from your chapter 2 logic chapter, when we do the converse, we do a flip-flop. We flip the if and the then. So back in section 2, you were told that the lines were parallel, and then because the lines were parallel, you could state that those special angle pairs were congruent or supplements. Now they've flipped it, and now they're telling you that if two lines are cut by a transversal and corresponding angles are congruent, then you can show that the lines are parallel. So given this picture, I could come up with a statement. So I could state, based on this picture, that if angle 2 is congruent to angle 6, then J is parallel to K. And the reason why I can state that is because of my corresponding angles converse theorem. That's why I can come up and decide that these lines are parallel. So again, we're still using all of those special angle pairs. Now we're just going to show that the lines are parallel. The next are the converse of the alternate interior angles theorem and the converse of the alternate exterior. So here, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Or we could also state that if alternate exterior angles, this converse says that if two lines are cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. So I'm going to actually draw a picture, and then I'm going to put some numbers on it so we can write some statements using these two converses. So up here in the corner, I'm going to draw two parallel lines, and I'm going to cut it by a transversal. Remember, when these two parallel lines are cut by a transversal, it creates 8 angle pairs. So I have angle 1, 2, 3, 4, 5, 6, 7, and 8. So if I add some congruency marks to angles 3 and 6, I can state that if angle 3 is congruent to angle 6, if angle 3 is congruent to angle 6, and then I'm going to add in, this is line P, and this will be line Q, then I could state that P is parallel to Q. Now, I could have also used the angle pairs 4 and 5 instead of 3 and 6, because 4 and 5 are also alternate interior. I can do the same, use the same picture for the alternate exterior angles converse. So if I add some congruency marks to angle 1 and 7, or even 2 and 8, I could state that because, or if, angle 2 is congruent to angle 8, then I know that P is parallel to Q. Or if I didn't want to say 2 and 8, I could also say angle 1 and angle 7. So if they have congruency marks on there showing that those angle pairs are congruent, then it's your job to identify them as alternate exterior, and then you can show that the two lines are parallel. We have one more special angle pair, and remember those are the consecutive interior. And that'll be on the next slide. The next converse is the consecutive interior angles converse. So this one states if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. Remember, this is that only special angle pair where the angles are supplements, not congruent. And again, I'll add a picture for you, and then I'll show you where the consecutive interior angles are located. I'll go ahead and draw them right here. Here's my transversal. And then I can add in a pair of parallel lines, or at least I think they are. So then I could say that this is M and this will be N. And let's say we add some numbers. 1, 2, 3, 4. Let's say they actually labeled our picture with numbers. Let's see, they told us that angle 2 was 110 and angle 3 was 70. So if I could show that 2 plus 3 equal 180, then I can show that the lines are parallel. And they are. So I could say that if angle 2 and angle 3 are supplementary, then M is parallel to N. You could do the same thing with 1 and 4. If they gave you numbers on them, you would just confirm that they add to 180, and then that would make them supplements, and then you could say that the lines are parallel. Okay, so someone asked me what's the difference between a converse, a theorem, a postulate. So a postulate is based on fact. A theorem is something that could be proven. And then a converse is the flip-flop of a theorem. So all of the theorems we're seeing today are all the flip-flops of the 3-2s. So in 3-2, when we learned about the consecutive interior angles theorem, it stated that if two consecutive interior angles are supplements, or no, they would start out with by saying that they're parallel. So yet in 3-2, we were told that if two lines are parallel and cut by a transversal, then consecutive interior angles are supplements. So when we learned it in 3-2, the if and the then were reversed. So remember, the converse flips it. So it's the same information, it's just flipped. All right, we have one more theorem in this lesson. It's not dealing with special angle pairs, it's the transitive property of parallel lines. So the transitive property of parallel lines states that if two lines are parallel to the same line, then they are parallel to each other. So just like we saw the transitive property of equality and of congruence, now we have the transitive property of parallel lines. So I'll go ahead and draw 3 parallel lines. So we'll call this J, K, and L. And we could put a transversal in here. So I could state that if J is parallel to K and K is parallel to L, then I know that J is also parallel to L. Because remember, for transitive, these middle guys cancel out. So if J is parallel to K and K is parallel to L, then I know that because of this overlap, this one is also parallel. You wanted me to explain this one again. So basically what they're telling you is you're going to be given that these two are parallel to each other and these two are parallel to each other. So because they're both parallel to the same line, they're both parallel to K, then I can also conclude that the beginning to the end, J, is also parallel to L by the transitive property. So here we have the ways to prove that two lines are parallel. So if you're writing a proof and they're asking you to show that two lines are parallel, you're either going to come up by showing that a pair of corresponding angles are congruent, or you could show a pair of alternate interior, or, and we can add this word in here, or alternate exterior angles are congruent, or show that a pair of consecutive interior are supplements or supplementary, or show that both lines are parallel to a third line. So that last theorem we learned, the transitive property of parallel lines. So this would be what you would do if they were asking you to prove two lines to be parallel. Somewhere in your proof, you're going to have to show that you have a pair of corresponding angles that are congruent, a pair of alternate interior, alternate exterior, any one of those three show that those angles are congruent, or show that you have a pair of consecutive interior that are supplements, they add to 180, and then the last way is show both lines are parallel to a third. The more common ones are the top three. Those are going to be the ones that you're going to use the most. In the next section, which we won't start until Friday, there'll be one more theorem that we're going to learn, and that's going to be dealing with perpendicular lines. But that'll be coming from 3-4. Let's try some examples. So let's try to figure out which segments are the parallel lines here, or the parallel segments. So remember, to prove something is parallel, we either need to show corresponding angles congruent, alternate interior angles congruent, alternate exterior, or show that same side interior are supplements. Now at first glance, you're going to be like, I don't see any numbers that are the same. However, if we go ahead and add these up, so let me add another point here. Let me just put a point G here. So let's say I treat this CAB and add 24 plus 36, and this would give me 60 degrees for that whole angle there. And then if I do the same thing for the EBG, if I add this, 22 plus 38 also gives me 60. Now I actually have two numbers that are the same. Now I got to figure out where are the parallel segments though. So where the two sides of the angles overlap, so like if I were to keep going and see how the red and the blue share this side, the side that's shared is always the transversal. Then the other sides of the angles that aren't shared, like if I were to continue this red line, this would be the parallel, the red and the blue. Now, if it's easier for you to see it like this, and do this, and then here are your 8 angle pairs, 2, 3, 4, 5, 6, 7, 8. The two angles I'm referring to in this picture would be angles 2 and 4. Anybody know what kind of angles those are? Corresponding. So I could say that yes, AC is parallel to BE, and the reason would be my corresponding angles converse theorem, because these are corresponding angles. So again, the parallel lines aren't the shared side, the transversal is. Up in this picture, my corresponding angles would be where the black things are, so it's angle 2 and angle 4. Those would be the corresponding angles. So corresponding angles are on the same side of the transversal, but one's inside, one's outside, but they can't be adjacent. So that's what I have here with the red and the blue angle. That's 60 degrees. Let's try another example. So here it says, what value of x makes AB parallel to CD? So here is AB. Here's CD. This is my transversal. And again, we're talking corresponding angles here. There's a little box here. So this tells me this angle is 90. So in order for the angles, for these lines to be parallel, these corresponding angles need to be congruent. So in order to figure out what x is, I'm going to do x plus 40 and set that equal to 90, because these two angles need to be congruent. Subtract 40, and the value of x would have to be 50 degrees. Again, these are corresponding angles, and what I could do is once I show that those corresponding angles are congruent, it makes those lines parallel. In the next lesson, which we'll learn on Friday, and again, you can't use this on the test because we haven't officially learned it, but in the next lesson, you're going to learn lines perpendicular to a transversal theorem. And what that'll state is if two lines are perpendicular to a third line, then the lines are parallel. And that'll be coming in section 3-4. Okay, let's try example. Here it wants us to find the values of x and y that make J parallel to K and L parallel to T. Now, sometimes you're going to have to rotate your iPad or your paper, if you have a piece of paper, in order to see the relationship of these angles. So let's go ahead and take a look to find the value of x first. So what I can do is like trace over what's making the angle. So here's angle x, or 3x. That's where x is located. So what I need to do is figure out, are they going to be the J and the K or the L and the T? So if I go ahead and trace over the only other angle that has a number, see how this would be a shared side? So that would be my transversal. And then I could extend this. And then these are the parallel lines I'm referring to. So now, what kind of angles are the 3x and the 60? Anybody know what kind of angles?
Supplementary.
I'm sorry?
Supplementary.
Nope, they're not supplements. They're corresponding. They're on the same side of the green transversal, and then one is inside and one is outside, or they're in the same corresponding spot. So I know that corresponding angles are congruent. So I'm going to set up my equation as 3x equals 60, divide by 3, and x equals 20. Now, for y, I'm going to use a different set of parallel lines. So if I go ahead and maybe erase, let's see. It's going to let me erase. Everybody got this? I'm going to change colors, I guess. I guess I could do a different.
Wait,
I'm sorry?
Never mind.
All right, I'm gonna just change color. So now I wanna work on finding the value of y. So here is 2y. So if I outline that angle, that makes 2y. Again, I'm gonna use the 60. So then here's my 60. And again, see the overlap, that's your transversal. And now I would extend the yellow this way and then extend this one this way. So now I need to realize what kind of angles are these? Alternate interior. So I know that alternate interior angles are congruent. So I'm going to do 2y equals 60, divide by 2, and y equals 30. And the reason why I can do this is that because these are alternate interior angles, and they already told me that line LT would be parallel. So this one's using alternate interior, and then this one was using corresponding. We have one last example. It's a word problem. So here it says, how can you tell whether the sides of the pattern are parallel in the photo of the diamondback snake? So notice they've taken this little circle and they've enlarged it. And I know the red markings are a little hard to see, but notice they've got congruency marks here. So this is congruent to this. So again, if you trace over this, they want to know if these are the parallel lines, and then this line would be your transversal. And I could say, yes, those blue lines are parallel because of the alternate interior angles converse. So I could say that if alternate interior angles are congruent, then the lines are parallel. So yes, they would be parallel because I've got congruency marks on those two angles. So we're still using the same angle pairs that we learned about in sections 1 and 2, but now we're reversing it and we're applying the converse for all of those. Yes? Yes. Okay, so now what we're going to do is start going over the worksheets that you had for homework that were due today. So go ahead and open up those. Anybody still need this last example?
Can you go back to example 1?
1?